Welcome to lesson 3 of 3-unit inequalities. Today we'll be doing rational inequalities. Rational inequalities are also known as inequalities with variables in the denominator. Now, what's so special about variables in the denominator, you ask? Well, think about it. Let's say you have the following inequality. 5 over x minus 4 is greater than or equal to 1. Normally, if it was an equation and not an inequality, if it was an equation, you'd just do this, multiply x minus 4 on both sides. And this seems like the logical thing to do over here, right? It's like logical. That's the first thing you'd think of. However, we have a problem. Do we flip the inequality sign or not? Because we don't know if x minus 4 is negative or positive. Remember, if you multiply by a negative number or divide by a negative number, you must flip the inequality sign. But over here, we don't know if x minus 4 is negative or not, right? So we don't know if the inequality sign should be reversed or not. And this is why we have to deal with rational inequalities using a special technique. There's a few ways you can go about doing it, I guess. The one that your textbook uses is to multiply both sides by the square of the denominator. Noting that the square of a number cannot be negative. So if we multiply by a number we know is positive, we don't have this problem anymore. This is what your textbook favors. And you're more than welcome to learn from textbook if you want. And when I say your textbook, I mean the Cambridge 2019 textbook. It's very algebra intense. Anyway, another way to go about doing it is to use the critical values, very similar to the quadratic inequalities that we covered earlier. And there's also a factor table method, which is kind of similar to the critical values method. Slight differences. I haven't seen that taught in Australia. I've seen it in textbooks used by, American teachers more than any others. Anyway, today we'll be doing the critical point method, and the reason I've chosen to do this is because very similar to the quadratic inequality method you've just finished learning. I think that the less you have to remember, the better. So rather than teaching, different techniques for everything, it's better to just have the one technique for as much of the stuff as possible. So you already learned this technique in quadratic inequalities. You might as well learn the same technique and just learn to apply it to rational inequalities. So a quick refresher: for quadratic inequalities, we factorize and find the zeros. The zeros are critical values and create regions. We test each region and get our solution. And it's very similar. Steps for solving with rational inequalities, very similar. So here are the steps. First, find when the denominator will be equal to 0. This is the first critical point, because you can't divide by 0. Because you can't divide by 0, it's a critical point, I guess. And I've written can't divide by 0 in bold, underline, italics, bigger font size, just to really, drill into your mind. So you can't divide by 0, ever. Don't ever divide by 0. Weird stuff happens. And also, solve the inequality. Step 2 is solve the inequality as if it were a normal equation. That is to say, find the zeros just like in quadratic inequalities. So step 1 is the main difference between quadratic inequalities and rational inequalities. And step 2 is where you basically find the rest of the critical points, just like you did in quadratic inequalities. So you'll get at least one critical point here, and you might get 1 or 2 more in step 2, and the rest of it is really the same. You have critical points, plot a number line, put the critical points in, test each region, and you'll have your solution, and then draw a number line and mark in your solution visually as well. So for example, let's go through a worked example. Solve the following inequality. 3 over x minus 2 is more than or equal to 4. Step 1. When is the denominator going to be 0? Just look at over here. When will this be 0? When x is equal to 2. 2 minus 2 is 0. Right? That's our first critical point. Or you can just write x minus 2 equals 0 and just solve it. X is equal to 2. Now I've put that in red because that is a special critical value. You can't okay. Note over here it says more than or equal to 4. This can never be equal to 2. Like when we're finding the solution, x is equal to 2 will not be a solution ever, because then this will become a 0. So when we're marking this on the number line, we have to remember and do an open circle at x is equal to 2. regardless. Okay, the other critical values, they will be filled in circles, but x is equal to 2 will be an open circle because it can't ever equal to 2. Hopefully that made sense. Alright, step 2, treat as an equation and solve for the variable. So we just treat as if it was a normal equation, right? And now we can multiply x minus 2 to that side, right? And we just do it, expand the brackets, solve for x here, x is equal to 4. X is equal to 11 over 4. So what I like to do in exams and paper is when you find a critical value, draw a rectangle around it. Make it very clear to the marker. And yourself as well. It's very easy to sub in the wrong numbers. Just do it like that. Just draw a rectangle around critical values, and you can write. You can even write, critical point 1, critical point 2 if you want. All right. So just making it into a mixed numeral. Now we test each region. If you want to, if you need help visualizing it, you can always plot it in. You can say, okay, well, that is equal to 2 over here, and it's going to be an open circle. I always like to do this first. Before I start testing region, I draw a number line and I do the open circle, closed circle, then and there. This helps me from making a silly mistake when I'm writing the solution later on, because it's so easy to forget, x is 2 part of the solution or not. So you draw the number line, you do the empty circle or the filled in circle straight away. Alright, so it's going to x is equal to 2 3/4. So let's say that is 2 3/4. I draw a circle here, but it's going to be a filled in circle this time. Okay, so empty circle, filled in circle. I've done that straight away before I even start testing the region. Then I'll start testing the regions. Okay. And I'm just going to wipe that off. Alright, so we test each region for x is less than 2. We pick a number. I've chosen -10. You sub -10 over here. 3 over 10 minus 2. For less than 2 I chose -10. So 3 over -10 minus 2. Is that more than 4? More than or equal to 4? And it is not. -10 minus 2 is going to be -12. 3 over -12, it's going to be a negative number. Negative number cannot be more than 4. You can use a calculator if you wish. Put this in your calculator and check if the answer is more than 4. You'll find it's false. And for 2 is less than x is less than 2 3/4. I chose 2.5 because that's 2. That's 2.75. A number in between those two numbers, 2.5. Put on the calculator. Is that more than 4? You'll find that it is more than 4. And same over here. Now notice that I've put a question mark. This is to really make it clear that I'm testing if it's more than or equal to 4. This is what we're doing over here. We're testing each region. Alright, and then you choose a number that is greater than 2 3/4. I chose 5. Put in a calculator, see if it's more than or equal to 4, and it is not. So our solution is that region, clearly. This is the only region where the inequality holds true. Alright, so another solution. Now remember, because this was x is equal to 2 and this will not be part of the solution, we write a less than sign here. Less than sign here. And over here we write less than or equal to, because in our question we have greater than or equal to. So greater than or equal to, this will also be equal to. So 2 3/4 will make that whole thing equal to 0. Alright, so plot this on a number line and that's it, you're done. Note, open circle, filled in circle. Alright, moving on to the next question. I've got no idea what that calculator thingamajig is doing. Anyway, check your understanding, pause the video now and see how you do. Give it a go. Alright, I'm assuming you've done that, so let's go through and see if your answer was correct. Now, step 1, where is the denominator equal to 0? X plus 4 is 0, x is equal to -4. Mark it in somehow so you know this is not going to be part of the solution. Step 2, solve it as if it were a normal equation. Multiply x plus 4 onto the other side. Expand the brackets, take those 6 to the other side and solve it, and you'll get x is equal to -4 and 5/9. This is our second critical point. Now we test each region. So you have -4, -4 and 5/9. This is around -4.555555. This is -4. So sometimes use your calculator and find the decimal value. It will help you in actually, finding out what the number actually is. And so when you have to test each region, you'll know what number to substitute in. Alright, so for a number for the region x is less than 4 and 5/9, -4 and 5/9, I chose -5. You can choose whatever number you want. I put it into the calculator and you got the answer. -5 is more than -9. That is not a solution. Similarly, I chose a number. I chose -4.1. Sub it into the calculator. You get true. For more than -4, anytime you can sub in 0, you try and sub in 0. 5/4 is positive, and that's definitely not less than -9, because a positive number, and that's a negative number, a positive number will be more, obviously. It will be greater than a negative number. And the calculator input over here, no. Yeah, I'm not sure what that thing is. Just ignore it. Sorry, it's just a mistake on my part. Alright, now we test each region. We've tested the region. We know where the inequality holds true. It's the solution somewhere over here. So we write it down, noting that that was a less than or equal to, so our solution will also be by default be something like that. However, because we have the denominator is equal to 0 at -4, this is not part of the solution. We draw a strict inequality there. Alright, and we just plot it on the number line and we are done. And hopefully you got it right. Alright, so what about if you have a variable on the top and the bottom? Well, the good news is nothing really changes. It's just the same as before. Step 1, where does the denominator equal to 0? Solve for that. You get x is equal to half. That is our first critical point. Step 2, treat it as an equation and solve for the variable. 2x minus 1 onto the other side. Expand the bracket, solve for x. And you get x is equal to 0.55555 repeat, or 5/9. Alright, so we will now test each region. As always, look, if you feel more comfortable doing it like this, if you want to really visualize it, plot it in. That's 0.5 and positive, so this is 0.555 and so on. And test each region. Find a number here, so you can have like 1, for example. Over here, okay, really think about what is the number between 0.5 and 0.5555. Note, you can put this 0.500. So a number over here would be 0.51 or 0.52, 0.53, 0.54. Even 0.55 will be less than 0.555. And obviously this is a repeater, right? This is just going to keep on going. Anyway, and then you test that region. Pick a number. You can pick 0 for this region. If it helps you visualize, draw the number line straight away. I would recommend that for you guys because you're starting off. Anyway, you test each region and you will find that subbing in 0, numerator is 0, therefore false, 0 is not more than 5. Subbing in 0 makes that whole thing 0. The top can be 0, that's fine. It's just the bottom, the denominator, that cannot be 0. Alright, and then we find that is the region, that is the solution. We mark it in. Note that was a strict inequality, and therefore we have strict inequality symbols over here. Sorry for that. Strict inequality symbols there. And then we draw a number line and then we mark in the solution. Alright, so check your understanding. Give this question a go. You should be able to give it a go. It should be fairly easy to do. Pause the video, give it a go. Alright, I'm assuming you've given that a go. And let's check if you got it right. So first step, where is the denominator equal to 0? No, it's always the same thing. It's just a procedure and it never changes. It's very straightforward. You just have to learn the procedure. Just follow it. Just follow the procedure, you get your answer. It's very straightforward. There's not a lot of thinking involved. Alright, so y plus 1, y is equal to -1. Treat it as a way to solve the variable. Y plus 1 goes to the other side. Expand the bracket, solve for y. Y is equal to -2. We have a second critical point. There are now, okay, so y is -1 and y is -2. These are our two critical points. We have 3 regions. Test each region. Y is less than -2. between -2 and -1, and more than -1. So I've chosen -3 for this region, -1.5 for this region, and 0 for this region. It's just calculator work, honestly. As you can see, I just put in the calculator, and you just check, is 1.5 less than 2? Yes, it is less than 2. Is 3 less than 2? No, it's not. So we are subbing it in. We are subbing it into this equation. Just a quick reminder, right? And yeah, we have our solution regions. This region, y is less than -2, or y is more than -1. So we write it in. It was a strict inequality, so we write strict inequalities there. Plot it. Easy. Fairly straightforward. Alright, so let's say you had something a little more complicated. I wouldn't say necessarily harder, a little more complicated, but as always, the steps don't change. Step 1, where is the denominator equal to 0? We just rewrite our denominator, and we let it equal to 0 and just solve. Very straightforward. Okay, that t is equal to 2 2/3. Create this equation, solve for the variable. So 3t minus 8 goes to the right hand side. We'll multiply both sides by 3t minus 8. And we just, do a bit of algebra, jiggling, move stuff here and there. 3t minus goes to the left, 4 goes over here, blah, blah, blah. You get t is equal to 2/5. That's our second critical point. Now, obviously, you have two regions, and look, I'm getting kind of tired of saying the same thing over and over. Hopefully, you get the point. It doesn't really change, right? It doesn't change. The procedure is the same regardless of the question. Test the regions, use our calculator. Now, over here, if you test 0, that becomes 0, that becomes 0. You use a 4 over -8. In other words, -1/2. Think about that. 4 over -8 is -1/2. So it's -1/2 more than -1. Yes, it is. It is to the right of -1 on a number line. Anything which is to the right, that's 0. That would be -1. That is -1/2. Anything to the right is greater. Anything to the left is less. So it's true over here. And then you test 1. If you test 1, 7 plus 4 is 11. 3 minus 8 is -5. And is that more than -1? No, it is not. And similarly for a number more than 8/3, it's just picking a number, pick anything. You can pick a very large number, and you will find that that will become 7/3. Right? If you have a sufficiently large number, then you don't have to worry about the 4 and the -8 because they become insignificant. Think of it like as infinity. If you have 7 infinity plus 4, 4 is nothing in comparison to infinity. And you have -8, 3 infinities minus 8 becomes insignificant. You have 7 infinity over 3 infinity, the infinity cancels out, you have 7/3. So for a sufficiently large number, this will be roughly 7/3. Positive 7/3. Is a positive number greater than -1? Yes, it is. And I know that sounded really sketchy and dodgy. You will do something similar to that later on in the 2-unit course. You can substitute a number that you want if you wish. It's up to you. Anyway, and we just write our solution. Note, of course, that was more than or equal to, so by default, our answers will be less than or equal to or more than or equal to. However, this inequality was the denominator equals to 0. It has to be a strict inequality, so we write negative because of that. 8/3, so that's how we write this. Alright, plot on the number line and you're done. Alright, so check your understanding, pause the video, see how you go. Alright, I'm assuming you've given it a go. Where's the denominator equal to 0, solve for that, treat it as an equation, treat as an equation and solve for the variable. Just algebra hocus pocus, x is equal to -1. Now we test each region, hopefully that's what you got, mark in the solution, and then draw in the number line. And of course I think I have made a small mistake because that's less than or equal to, so this should be, let's see, -1/5 will be the strict inequality, and that should be like that. Alright, and then just marking the number line, of course this will be a filled in circle, and that will be a strict inequality. Okay, so homework. to the homework sheet given by Mr. Shakir. It will be up on Slack if you've lost it. And once you've consolidated this lesson, you should attempt Cambridge 3-Unit Textbook Chapter 5A. We have done all of 3-Unit Inequalities. You should be able to attempt every question in that chapter. And it'll be good revision of everything that we've done, I guess. So best of luck.